Hi there, guys. This is 14N and 14O. So 14N is about choice, validity, and interpretation of tests. And what's O about? O is about, oh, it's quite a lot of questions on that one. And then choosing a valid test. Valid tests, content validity, reliability of tests, test retest models, parallel forms. It's just a lot of stuff which we're just discussing here. Obviously, you can do this by reading this through yourself, but I will just try and pick on some of the key examples here. Okay, yeah, choice, validity, and interpretation of tests. So it says the process of conducting a statistical test is far more than just analyzing the data. And in this section, we are looking at the considerations you need to make. You need to make in choosing a test to use, and checks you need to make to check your test is valid and reliable. Okay, so collection of data to start off with, and as I said, I'm going to pop straight to the examples here. So an example of a problem with your collection of data could be a systematic error, say, for example, in a weighing machine. This might still provide you with some good correlation, but it's going to be slightly off every time if your weighing machine is always adding a slight amount to your to the weight of something or other. So there could be errors in so non-random errors, for example, in how your data is collected. Okay, and yeah, they're talking about their or it could be random due to natural variation or other unknown factors, which might be expected to have a zero mean. Okay. So selecting the sample as well. We talked in chapter 2 about the types of samples there are: simple, random, convenience, systematic, quota, and stratified. Quota, by the way, is different to stratified. Most people get those two kind of confused. Quota being a non-random sampling method, essentially saying, well, I want to have 50% men, 50% women, potentially based on the strata in the population as well. I might want 20% of people from year 10 in my sample. So the quota would be basically, I would take people potentially coming into the school in the morning, and I would say, okay, I take these people until I've had my fill of my quota for year 10 students, for example. Okay, that's not random. That doesn't mean to say that everyone has an equal chance of being picked. That's just fulfilling quotas based on some element of convenience there. Okay, now they talk about collections using questionnaires. So there are a lot of these are sort of common sense. We're talking about questionnaires potentially having multiple choice or short answer surveys. Make sure that answers are not restrictive. Make sure that people answer honestly. Potentially, if a question is not anonymous, questionnaire is not anonymous, or survey is not anonymous, then people will be less honest. Question may be interpreted in different ways, so obviously it needs to be extremely clear. You should not have leading questions, of course. Don't you think that you should vote Labour in the next election? You shouldn't lead people to a conclusion. And the questionnaire needs to be complete, as extra questions cannot be asked later. Okay. Another good thing to note is if you are genuinely making one of these up later on, is that if you've got a choice between good, bad, and I feel indifferent about this, lots of people tend to go indifferent in the middle. It gives you no indication as to whether you're one side or the other side in terms of your leaning for something or other. So it's often better to have 4 options for your satisfaction than it is to have 3. Okay, let's have a look at the next bit. Data mining. Okay, so we're coming up to a question on this one. So data mining occurs when lots of paired variables are considered. So it's when you do a ton of research and you get lots of variables which are potentially associated, and you then do tests on whether or not these things are dependent or reliant on each other, for example. They say if enough variables are compared, it is very likely to have such results that such results can be found. So we're talking about significant results here. As significant results will happen by chance 3% of the time, 5% of the time. Now that's called a type 1 error. That's accepting the alternative hypothesis when in truth this has just happened according to random error. So in fact, the null hypothesis is true. So let's have a look at example 17 then. So example 17 says a questionnaire is compiled asking a group of people a series of questions about 5 unrelated qualities. The answers to each set of questions are then compared with the answers to each of the other sets using a chi-square test for independence to see if there's significant evidence that they are not independent. State the number of tests the compiler of the questionnaire will have to perform if they are to compare every possible pair. Okay, so you've got 5 qualities that can be paired up with any 4. So there's 4 tests there. And then you've got those 4. Let's copy this one. Okay, I might need a little explaining here. Okay, so we've got 5. So we've got 1 based with 1 and 2, 1 and 3, 1 and 4, 1 and 5. And you can essentially count through these actually, because then you've got 2. Well, 2 and 1 has already been done. So now we're left with 2 and 3, 2 and 4, 2 and 5, and 3 and 4 and 3 and 5, and then of course 4 and 5. So there you go. There's 10 tests there, which we've got. So you could just list them if you wanted to. That's just 4 plus 3 plus 2 plus 1. The book does that slightly differently. It says, look, we've got 5 of these qualities matched up with any 4, but then if we match them up every 5 with the other 4, then we've doubled all of our amounts. So for example, in this case, we would be adding in 2 and 1. And in this case, we would be adding 3 and 1 and 3 and 2. And we'd have 3 there and we'd have 4 there as well. So those would be duplicates of other ones which are there. So you can do 5 times 4 divided by 2 if you want to there as well. Okay, that's also giving you 10. Okay, for part B here, it says, given that these tests are all at the 5% significance level, find the probability that at least one of them will prove to be significant, even if the qualities referred to in the questions are independent of each other. Okay, so we're looking for the probability that there is at least one of them proving to be significant. So the probability of at least one of them being significant is the same as the probability of 1 minus there being no cases which are significant. So the probability of no significant relationships. Okay, so probability of no significant relationships. Now, the probability of no significant relationships is really easy to find because that's 95% of the time for 5 tests in a row. So that's 0.95 to the power of 5. So it's 1 minus this. That's going to be your answer to part B. So you need to think about that the other way around, because at least one will be saying, well, 1, 2, 3, 4, 5, 6. So then I suppose you could do a binomial distribution as well. So how would you do that? You could do X is binomially distributed, and the chance of success is 0.05, and there are 10 tests. So you could also look at doing the probability that X is greater than or equal to 1 there. It should give you the same answer. Okay, so yeah, there we go. That's that. I think that's the end of that exercise. Data mining, a little bit more. It says, data mining is a useful technique to highlight possible connections between variables, but if there is no external evidence in support of a connection, then the test must be repeated to see if similar results are obtained. Okay, so if you're comparing many variables from a survey which you've brought in, if you think that you found a relationship, you need to repeat that test if you're doing data mining. Okay, so then there's quite a lot of questions in 14N. I'm going to skip past those. Now we're talking about valid tests and reliability of tests, and so a lot of this stuff is fairly common sense. So for the next exercise, they talk about valid tests to start off with, and there's various types of validity for tests, which they mention. So first of all, what is a valid test? A valid test is one that measures the quality it claims to be measuring. Okay, so there's content validity, criterion validity, and predictive validity. So let's look at an example for this. For example, a test on quadratic equations has content validity for testing how good a student is at doing quadratic equations. So it's testing the content there. Okay, and so that's kind of like a normal test, right? Now, predictive validity, I'm going to skip criterion validity here. So predictive validity here says if an example of this, rather, it says an example of a test with predictive validity might be a total point score in the IB and future success at university level. Okay, so we can't possibly do a content validity test for your future success at university, but we can make a prediction based on some previous combination of tests, for example, or potentially your mathematics test is a good predictor of your physics test result. So that could have predictive validity as well there. Okay, well, when it says here as well, criterion validity, so that's kind of nuanced, really. That's a little bit in between the two. That's saying, in addition, if previous experience with a test has shown that a high score in a test is a good indicator of success in, say, for example, a more advanced algebra test, then there is criterion validity. So if your first algebra test is quite a good predictor for the same thing the same criterion, in other words, algebra, but with a more sophisticated later test later in the course, then it would have criterion validity. That was slightly different to predictive validity because the predictive validity wasn't necessarily based on the same criteria. Okay, right. Okay, reliability of tests. Now, if something is reliable, let's just flick down a little bit here. If something is reliable, then you should be able to do, if a test is reliable, then you should be able to redo the test and to get the same result. That would be an indicator of a reliable test. Now, what does it say up here? It says, a test or other means of collecting data is regarded reliable if it produces similar results on each occasion if it is carried out in similar circumstances. Okay, so there you go. If you can repeat it, it's reliable. A reliable test is not necessarily valid. So, for example, a test on quadratic equations could be very reliable. Because students will obtain similar scores each time they take it, but not valid for assessing their ability in a visual arts course. So it's obviously not valid if it's not testing the right thing, but it could be a reliable test. Okay, test, retest. To test that your means of collecting data is reliable, the same test or questionnaire can be given to the same group after a period of time. If that's the case, then it's reliable. I think we said that. Parallel forms of a test. If you have, if you make two tests which are of a similar difficulty, so you've got a whole set of questions and you split them into roughly their difficulty, and you create two parallel tests, you could give one test to a group of students, and shortly afterwards, the second test would be given to the same set of students. The test is reliable if you have a strong correlation between the scores achieved on each of the tests. Okay, so that's another way of testing the reliability of a test, is essentially to make a similar test up based on those questions. So you have 100 questions, 50 questions, one go one way, 50 questions go the other way. Is the test reliable? Well, if you're getting similar answers from both of these tests, then they are reliable tests. Okay, right. For parallel testing, you have to create a large number of questions of equal difficulty, and that's already a difficult task in itself. Okay, right. So there we go. Now you're on to 14O. I'm going to stop there. Hopefully that was fairly useful. You've got a lot of questions to have a look at there. The next little section is type 1 and type 2 errors, and then finally we're going to look at a bit of Bayes' theorem in the last exercise. Okay, thanks for listening.